In this video, we're going to talk about different types of errors that can happen during hypothesis testing. We're going to talk about type 1 error and type 2 error. Type 1 error is denoted by alpha, is also called level of significance. And type 2 error is usually denoted by beta. So the truth about the population parameter has to be either the null hypothesis should be true or null hypothesis should not be true, which would be equivalent to alternative hypothesis true, right? Because null and alternative hypothesis, these are two opposite statements. And just one of these two, and only one of these true, and always one of these two should be true about the population parameter that we're testing about, all right? So this is the actual truth about the population parameter. So we have two possibilities. But then when we run the test, when we collect the sample and we make the conclusion, when we do all those steps in hypothesis testing and make a conclusion, our conclusion can again cannot be out of these two options, right? So we either reject the null hypothesis or we fail to reject, or we do not reject the null hypothesis. So these two cases can happen in terms of our conclusion. So now, 4 cases in total can happen. Either the null hypothesis, again, one of these 4 cases can happen. In 2 cases, we're making right conclusion. So our test is performing well, performing correctly. If the null hypothesis is true actually, and we do not reject the null hypothesis, that is exactly what we should be aiming for. This is a good case. Again, this is a good case. If the null hypothesis is not true, if alternative hypothesis is true actually, and we happen to reject the null hypothesis, we take the alternative, this is again a good case. These are when the test is working correctly, working well. Right, so, but then 2 types of error can happen. The type 1 error is if actually null hypothesis is true about the population parameter, but the test actually, our conclusion based on the test would be to reject the null hypothesis. So obviously we're making a mistake here. Null hypothesis is true, but we're rejecting it. We're claiming that it's not true. So that is called type 1 error. Type 1 error, it's also called false positive error. If you take rejecting null hypothesis as positive and do not rejecting the null hypothesis as negative, so it's false positive. And then the other way around, we may have alternative hypothesis true actually in reality, but our conclusion might be not to reject the null hypothesis. We take the alternative. We take the null actually, and we're not able to reject the null. And again, this is a mistake. This is called type 2. These two are obviously different, and they define the way actually we're trying to test and we're trying to conclude. All right, so the different types of tests. And now just to make sure that we're understanding type 1 and type 2 errors, I have this example. I want you guys to maybe pause the video and think about this. So obviously in 2 cases, we have errors. One of them is type 1, the other one is type 2. And I want you to think about this for a moment yourself. All right, so I'm going to talk about the left panel, the left picture first, and then we talk about the second one. So before you can say if this is a type 1 error, type 1 or type 2 error, you need to know the you need to actually have your null and alternative hypothesis developed. What is the null? What is the alternative? So I'm going to write it down here. So I'm just going to type it here maybe. So the null hypothesis and then the alternative hypothesis. So the null hypothesis about any one, right? So here we need to make, basically we need to develop null and alternative. For pregnancy, pregnancy is something that is, again, this is something that is more like a claim. For that, you need to have a strong evidence. I mean, if you want to go out and say, I mean, tell someone that they're pregnant, you should have enough evidence for that. This is something that is not the common belief about every person that you see in the street, right? So you don't put it in here because null hypothesis should contain common belief, tentative conjecture. So that is not the case. Pregnancy is a special case, is actually your research hypothesis. This is something that you want to claim here, right? Pregnancy. And then pregnant, not pregnant, not pregnant. So our assumption about anyone is that they're not pregnant. So that would be null hypothesis. Now, this case, obviously, the null hypothesis is true. So case one, null hypothesis is true, but what we are doing, we are rejecting the null hypothesis. The conclusion of the doctor here, he says the person, the patient here is pregnant. So what he is doing, what the doctor is doing, the doctor is rejecting the null hypothesis. While we know that null hypothesis is actually true. So he's making a mistake, but this is the case. Null hypothesis is, in reality is true, but the conclusion is to reject the null hypothesis. So that would be a type 1 error. This picture is a type 1 error. How about this one? Again, there's obviously an error happening here. The patient, the reality of this patient is that the null hypothesis is not true. Actually, the alternative is true, all right? So the alternative is true, but the doctor is saying that you're not pregnant. So the doctor is actually failing to reject the null hypothesis. The doctor is not rejecting the null hypothesis while the alternative hypothesis is true. So this is a case of basically type 2 errors, right? So we have two types. You see the difference between these two types of error? Sometimes you have a false positive, right? So you're telling the person that your result is positive, you are pregnant. Here we have a false negative. While the person is, the patient here in this case, is pregnant, you're telling them that they're not pregnant, a false negative. Now, again, we denote type 1 error as alpha, level of significance, the probability of making a type 1 error, alpha. In all hypothesis testing that we run in this course and in practice, actually, in the statistics, we always take a fixed value of alpha. So we fix level of significance. We always fix level of significance. And then we measure beta and we measure the power of the test, 1 minus beta. I'll talk about those in a minute. But before that, we have, so alpha is the probability of rejecting the null hypothesis if the null hypothesis is actually true. Probability of making a mistake by rejecting the null hypothesis if it's actually true. So that is the level of significance. 1 minus alpha is called confidence level, and it's the probability of not making a mistake when null hypothesis is true. So if the null hypothesis is true and you're not rejecting the null hypothesis, this is called confidence level, and it's always equal to 1 minus alpha, right? Alpha is the one that we control. We usually take it equal to 5%. That's usually the default. You can take it, I mean, depending on the case, depending on the question, depending on the context, you may have to go with a smaller number, usually 1% or 10%. These are the most common one, 1%, 5%, and 10%. Beta, the probability of type 2 error, would be the probability of not rejecting the null hypothesis if actually, in reality, null hypothesis is false, is not true. So this is, again, this is an error, this is an error, this is a type 2 error, beta. The power of the test, now we have, similar to the confidence level that we defined, 1 minus beta is called the power of the test. Probability of rejecting the null hypothesis if the null hypothesis is actually false. This is when your test is performing right, performing correctly. This is the chance of telling a person that they're pregnant if they're actually pregnant. That would be the power of the test. Just remember this, a pregnancy test, the power of the test, the chance that the test correctly identifies and captures the pregnancy. If a person is actually pregnant, what is the chance that the test shows the result correctly? So that would be, that's what we call the power of the test. Beta cannot be specified. Again, in practice, what we do in the science of statistics, we always fix alpha, the confidence level, and we measure the beta if needed.